Awesome, and we are recording, so everyone can see my screen. We're recording with Streamlabs, and the exercise today is to review some concepts, maybe introduce some new concepts of classes and objects, and I've got some practice word problems that we're going to use just to practice some different object-oriented concepts. So I'll just start at the top, and I'll do one at a time. And my class is virtual today, so feel free, guys, to chime in, ask questions. We can have discussions around any of this stuff. Create an application named test classified add that instantiates and displays a classified add object. So when I read a classified add object, that's telling me right away we need a class called classified add. So, what is a classified add? I mean, you could think back to the days of the newspaper, and you could think of, the ads that you would run in the newspaper, or, much more modern, I guess you would say Craigslist. You can run an ad in Craigslist, that kind of thing. So classified add.cs. And I don't think it's anything critical, but I always change that to public because that's a habit. And then again, it's worth noting the name of the file and the name of the class. It's best practice that they match, and in some languages that's like a really strict rule. Okay, so we have a classified add has fields for a category. For example, used cars. So a field, right? That's our instance fields. And category. So that would be private string underscore category. Number of words. Well, an add has an int number. How about that? And a price. So you'll notice everything is private on our instance fields. And a price, we'll say decimal. And we'll keep the convention of underscore price. Includes properties that contains get and set accessors for the category and number of words, but only a get accessor for the price. Oh, so this is cool because we have not done what's called a read-only property. So you'll see that here. So now we have some properties, and they all have get and set blocks. So we'll say public category, and Visual Studio is pretty doggone savvy. Like, wow, that's almost too much. This is almost too much. Public int number of words. There is a shorthand notation for this. Which, I forget. So C# arrow syntax for properties. Just take a quick look at this. Come on, someone give me a straightforward answer. This is a challenge of using Stack Overflows. You get so much crap. Like, here's a method. Yeah, we know that. Okay. I'll look this up outside of the recording, no big deal. So back to the problem, since my shorthand notation is failing me. It says includes properties that contains a get incentive, but only a get accessor for the price. And then it's like, okay, you know, we can use the mutator here for category. We can use the mutator here for number of words, but kind of interestingly, there's only a get block for price. So public decimal price get return price. And so what this tells me in this problem is somewhere else we can't set the price using this. Like, how are we going to set the price? Like, that's the natural question, is how do we set the price? And so let's go back to the word problem. It says the price is calculated at 9 cents per word. Well, where do you set the number of words? Here we set the number of words in this property. So when we set the number of words, we know that the number of words is being set here, and it's going to be passed in as the value. So when we go to create this classified add, you know, we'll set the number of words, and at the same time we will calculate the price. So we can use value here, because value will hold the number, like, hey, there's 10 words, so value will hold the number of 10. So we can actually expand this set block out a little bit here, and we can just, instead of just doing one thing inside of our set block, we can also set the price equals value times 0.09. Now we got a type mismatch. You know, hey, it's saying, hey, you've got decimal, which is one thing we might need to do like this. There we go. So it's just basically saying this 0.09 was a double. We need to convert it to a decimal, so we can do it like that. So this is how we're going to set the price. Whenever we set the number of words, we also are setting the price. And this only has a get block, so we cannot set the price using the price property. We can only read the price. So this is called of course, a read-only property. And so, hey, right away, new concept. We got some nice review with our instance fields and our properties. But here's a new concept, read-only property. And because price is calculated based on another factor, which is the number of words, we go ahead and set the price when we set the number of words. And so if we're going to make a form, we'll up through this real quick. Let me drag that off. And I'll make a button to create and add. And I'll have a label for the number of words, because I need category and number of words. So we'll have two inputs. One input would be category. Label category. And the text says category. And this one says text box for category. Text num words, create and add. Now we don't have any sort of constructor here, right? So when we don't have any constructors, we have to use what's called the default constructor. So we create and add. So let's go ahead and string category is text category dot text. Int num words is int.parse text num word. So let's get our data into variables. Let's create an add object, which is called a classified add. Classified add New add is new. It's probably not a good identifier. We'll just call it my classified add equals new classified add. Again, you call this whatever you want. Maybe a better identifier would be classified add one. I don't, just thinking outside the box here, just trying to think of a good identifier. Point is, you get to name this. We're using the default constructor here. And then we get to go ahead and set classified add one dot category equals the category that we read from the text box. Classified add one dot number of words equals the number of words that we read from the text box. And let's have a label result. Okay, so we've created our, let's talk about what we're doing here. This is read the input from the GUI, create an add object, set the properties, set the values of the properties, right, using those variables. And now we're going to output the add to the user. And so if I say label result dot text equals the add category is, you would say classified add one dot category, which has this many words and costs this much. So how many words? It's going to be classified add one dot number of words and costs, so we can use the read only to get the price. Classified add one dot price. You can see price only has a get block, so you cannot set. This is the set block of these properties, but we cannot set the price. It's a read only property. And because that's a price, we could go ahead and put a currency on it and a semicolon. And if we run this, the add category is used car, which has 300 words and costs 27 bucks. It should be 27.09. So every time I click, I create a new add object. It sets the properties and does the output. Questions, comments, concerns? How
Can you like go and look in like the class part and kind of explain that a little bit?
what specific part would you like explained? So we've got the instance fields. This is our data. And so it's all about working with the data. This is the most important piece. I'll say that 100 times in this class. I hope I say it 100 times. The data is the most important piece. And so these properties are just working with the data. And so when I say working with the data, we're either putting data into these fields or we're reading data out of the fields. And so the set blocks right here, if you see what's happening, we're assigning the field underscore category equal to something that gets passed into this class. So we're either putting data into category or we're reading the category with the get block. So get block reads, set block writes. Get block reads, It just so happens that this number of words is a write operation for two properties because it's dependent. The price is dependent on the number of words.
I have a question. How is value actually getting its value? Where is it getting that from?
Yeah, so it's probably worth a breakpoint to see that. And so what I'll do is I'm going to put a breakpoint right here. You can see here we're using the category set block. When we use dot category equal to something, that's going to call the set block. And it's going to pass in the category, which is our variable, which is coming from the text box. Right? So let's follow that. Let's start debugging. Good questions, guys. So if I say toys, 10, capital T. Okay, well you can see toys is our category. You know, we're reading toys from the text box, storing that in category. We're then passing the word toys into the set block of that property, because this is using the category property. And so the question that's very common question is, oops, let me do that again. I don't want to step over that. Start debugging. It says it steps over it. I don't want to step over. I want to step into. So I'm gonna, instead of putting my breakpoint right here, I'll put my breakpoint in right here. And so I actually stop on that line of code. So toys and 12. So the question is, what is value? Value is being passed in from the method, you know, the button click, essentially. So in this case, value comes in as toys. Do you kind of see that now? Where I hover value and value is toys, because that's what's being assigned to the category set block right here.
So could value be called like anything? Like, could you also just call it category?
No, because it's a keyword. It's kind of magic, if you will. I hate that that's how I have to describe it, but it's always just whatever the value that's being passed in. So it's a keyword. You can't call it anything else. It has to be value.
I have another question.
Yeah, right.
So in each property block, the get is in there before set. I don't really understand, how can you set it, or how can you return category if category isn't anything yet?
Yeah, that's just how I happen to code it. When you're coding this, as it turns out, the organization here doesn't really matter. Like in our minds it matters, but this could be coded in all sorts of weird ways, is like what's above and what's below one another. The set block can go above the get block, because this code isn't running right away. It's running later on. And so you're just using these pieces of code as they're needed. And so what happens here is that companies basically say, okay, at our company, we put our instance fields at the top. You know, so different companies will organize their classes and all of the members of their classes differently. So they'll say, hey, I'll put my fields at the top. I'll put my read-only properties beneath my read-write properties. So these are read-write properties. And at our company, we're going to put our set blocks above our get blocks. And it just turns out, you know, to answer your question, it doesn't matter. There's what does matter is that you follow your company's convention. Does that answer your question?
Yeah, I have another question.
Yeah, please.
So the price block, how does that get the price that's the number of words?
Well, you see, this is setting the price right here on line 21.
Yeah.
So the number of words is passed in as the value. So like, let's just say 12 words. So value is 12. So we set the price, the underscore price equal to 12 times 0.09, and this is setting that price, and then this is returning that price.
Okay, understood.
Glad you asked. Now when you have one price, like we have here, we can output our output like this. But yesterday we also learned the toString method. I'm going to take kind of this output and I'm going to put it in a toString instead. I'm just going to refactor my code just a little bit. And this would be very useful for if I had like 1,000 classified ads, we would use this toString method to help us with our output. So check this out. So public override, and then you pick toString. And this is what I'm going to do. So you can see that this method returns a string. And so what am I going to return? Well, I'm going to return all these things. I'm going to return a string that includes the category, the number of words, and the price. In fact, I can kind of take this, okay, and I'm going to paste it here and just make some changes. It says the add category is, and what you can do, instead of using the property, you would just say this dot underscore category. So you say, hey, use the instance field for this object's category, for this object's, this dot underscore number of words, and this dot underscore price. And so it says the add category is this category, which has this number of words and this price. And so let me show you how that would be, useful, because now when we want to output an ad, we just have to call toString and it does all of this, right? So instead of coding it, a bunch of times over here when we're using it, we would just say, this is called classified add one toString, right? So you could see as a user of the class, it really simplifies my output into this toString call, right? So that's a little bit of review from yesterday, but it's good to review. And we're going to find out we get the same output. Toys, 12 words, and cost $1.08. And so, let's show the benefit of, let's just say classified add 2 is new classified add. Okay. Now instead of using what the user puts in, right, I'm just going to say classified add 2 dot category is always going to be lawn equipment. I looked over and saw a leaf blower. Classified add 2 dot number of words is 1,000. So now I've got two objects, and now when I want to output label result dot text, I'm going to append the second one, classified add 2 toString. And so the output just becomes so much easier when you could just call a toString and it gives you the data out of the object that you want. You don't have to manually code all the data that you want using all the properties. You just use that toString. And so kind of glancing at this, so there's our first ad, and then the second ad, the ad category is lawn equipment. It has 100 words and costs $90. And so toString is basically the method. So if I write my little, what is toString? toString can be used to output the data from any given object, class or object. We'll just say object. Right? So what is the important thing that you're going to output on the data? So that's toString. Let's get some questions about toString.
I have a question.
Please.
So when you're in the classified add class, is there? So I guess you're setting it to the underscore price and underscore category, rather than using like the variable in the form. Is that right?
That is correct. Ultimately, the variable in the form, like here, was sent into the set block of category. If you go into the set block of category, we set the instance field of underscore category. So
So
it's
is Oh, sorry. Go ahead.
it's just following like the flow of where the data is going.
So is the get actually doing anything when you have? I guess it's returning category and then categories coming back to the toString.
Oh, good question. So like at this point, are we even using the get block of this property? And is that kind of the question?
Yeah.
And we're not. To be quite honest, right now, we're not using this get block. But that doesn't mean you have to delete it. I mean, just because... So the idea here is that, you know, one developer creates the class, and then this class can be used by anybody else. And so because I didn't use... So let's just say I create the classified add, and I give it to my team, and they could all use it. Well, one developer might not use the get block, and another developer would. You kind of get what I'm saying?
Right. That makes sense.
So it's like, you know, it's possible for us to use it, even though I don't have it being used in my current implementation. It's also worth noting that if I just print out the identifier, right? There's an implicit, which means automatic. There's an automatic call to the toString method. So this and this do the same thing. And I'll point that out. And you could see that my second classified add is still working the same way. It's still calling toString, even though we didn't explicitly call it. We used the implicit call.
So is there a reason that, like, is there something that could break if you don't use the toString call?
You can make the point that this is a little bit more readable. That line 40 is slightly more readable than line 41. That's really the only advantage of using one over the other, is that people who know this understand how that worked, but, you know, maybe not everyone knows that, so it's a little bit easier to comprehend. Does that answer your question?
Yeah, and then I have another question as well.
Please.
So whenever, because right now you're not using the get block in the class, but if you were to use the get block, would that just look like a normal label result text?
We were using the get block before. If you remember, we were saying label result.text plus equals classified add one dot category.
And then that's the get block right there.
That's the get block right here.
Okay.
So this calls the get block because there's no assignment operator. This calls the set block because there's the assignment operator, the equal sign. So right here is your call to the set block. Right here is your call to the get block.
Thinking about it with the assignment operator helps a lot.
Good.
So would you be able to use the toString method with like something else that you weren't like not the class?
It's really common to put them on. I would say it's a convention, if you will, that all of your classes typically want to override the toString, because it's like, okay, if you create this object, what data do you want to pull out of the object? And you put that in a toString. So this is very common. But your question is, is there a way to work with toStrings outside of a class? And not in my experience. It's always associated with the class.
Okay, got it.
Yeah. Okay, now. So let's focus on classified add to. So if we say classified add to, which is line 28, and then we put data into that add right here. So like really these 3 lines right here. Let's just look at these 3 lines. Okay. So we're looking at these 3 lines, and this is such a very common thing that they make a shorthand for this. So let's make another classified add. And you can actually see Visual Studio starts to complete this for me. This is using the default constructor, which means empty parentheses. So this is the default constructor. Curly brace, and then we can use our properties that have setters. See this? So this is kind of a quick way to fill our data. Category equals, and category is the string. And so we're just going to have trash cans, because I'm looking at a trash can, comma, number of words equals 22. So let me kind of get this all in a readable format for you. You could put it on 1 line, you could put it on 2. You might even see it like, you might see it like this. Right, so this is a semi-condensed version of this, especially if you get it down into 1 line, without all that extra white space. Kind of hard because I'm so zoomed in, but let me zoom out so you can still see everything.
And are you only able to do that shorthand with a property like you can do it with the other ways of making a class?
This is the way to do it with properties. There are other ways, as always, there's other ways. Because remember yesterday, what we haven't done here is work with our constructors. Right, so constructors are also ways of putting data into these fields. And maybe we'll do another problem and we'll focus on constructors a little bit. But this is, just wanted to show this syntax of having these properties used. Oh my gosh, I can't think of what this is even called. They have a name, they have a fun name for it, but I'm drawing a blank on it. Object, I think it might be called object initializers. Initializers, I believe that's right, but I need to double check my and object initializers, again, if that's the right term, is when you can use the set block at the same time of creating the object. Because keep in mind, the keyword new creates our object, and then you're using these set properties to set the values into the instance fields. Because that's exactly what we're doing here. And then we would do label result dot text plus equals classified add 3 and get the data out real quick. Now check this out. We got 3 outputs of toString, and I know that I need a line break, so I could just go right in here. I put 1 line break in, and that's going to be called 3 times, and so that's going to help me put line breaks. And so you start to see, hey man, I just made 1 change of code and it was done 3 times. That's some good code reusability. You start to see the efficiencies. Right? By making the change once, it's implemented multiple times. I'm going to, since I brought up the concept of object, yeah, I'm pretty sure it's called an object initializer. Yeah, that is correct. I got the right name. All right, good. Good teacher. I guess one last thing, and we'll do another problem, and then we'll get into lab. Using these object initializers, we can use them with a list. So let's just make a list of classified ads called local newspaper ads equals a new list of classified ad. Then we say new classified ad category. Okay, so let's break this down. So here's our list. Here's our list of classified ads. So let's just say we're going to have 3 of, 2 of them. It doesn't matter. Let's just say 2 ads. So none of this matters above. We're not using these. We're not going to use these right now. So let's comment all of that out. And let's comment all of this out. Okay, all we have now is a list of ads. And we have to create an ad object to add to our list. So here's our list of ads. And then our first ad is a new classified ad. So this is our position 0 in the list. And this will be used toys, number of words, 1. So let's then our second ad is a new classified ad. Category is used cars, comma, number of words is 2. Let's just copy this and just make a few more. 1, 2, 3, 4. We'll give the category of used cars, of used phones, used trash cans, used coffee mugs,
Use diaper.
used toilet paper. We're going on the same. Gotta spice this up a little bit. Okay, here we go. So we got a list of ads, and there you go. 1, 2, 3, 4, 5, 6 ad objects inside of our list. So that's putting the data in to our list. Let's loop through our local newspaper ads.count. So again, the count property is how many items are in the list. So, 6 items. So 0 through 5 is a 6 iteration loop. So this loop is iterating 6 times. And each time we'll say label result.text plus equals local newspaper ads sub I. Again, there's an implicit toString call. You can start to see how this stuff becomes pretty useful when you start doing this kind of stuff. how quickly, once we make this classified ad, now we can create a bunch of ads. All the ads have the same categories, the same number of words, the same methods, the same properties, and you can use them and reuse them and reuse them. So we're not even working with our input anymore. But there you go. We just get a bunch of ads, a bunch of categories, a bunch of number of words, and a bunch of prices. You see how reuseful this becomes. Was that a good demonstration? You guys like that? You got questions?
I like that word, reuseful.
Very reuseful.
Wait, so what exactly is it looping through? I'm confused about the whole dot count.
Yeah, what is newspaper ads? That is our list. Local newspaper ads is our list. So the count is the number of ads in our list. So if we count these, there's 1, 2, 3, 4, 5, 6. So this is basically saying I less than 6.
So does that have no upper bounds? Like if you just keep adding on, it'll always...
Yeah. So if we add on another one, it would automatically increase. Count is now 7 because there's seven ads in that list. Right? And because this list is a list of classified ads, the only thing we can go in, we can't put strings, we can't put ints. It's got to be a classified ad that goes into this list. Does that answer your question, Vinny?
I think so, yeah.
Yeah. And now it automatically loops one more time because the count has gone up.
Is the a list? It has like curly braces around all the like list items. Is that how it knows that those classified ads are in that list?
Yeah, if you kind of think of, like here we called this our object initializer for our classified ad, right? These curly braces are the object initializers for our list. This is like saying, okay, right away, put this data into our list. Because if we're not using this syntax, if you remember, how do we add another ad? We would say local newspapers ads dot, there's an add method. And you would do something like new classified ad here. And you would say right, so this is a way when you're creating the list to put data in right away. But if you create the list and then you want to add an item later on, you got to use the add method. And you can add a new object here like we did. Or I believe George did this one yesterday. Like if I say, let's bring this one back. Remember classified add 2. Right? So we have this object that's hanging out. And we want to add this object to our list. It's already been created. It's already put data into it. We could also do local newspaper ads dot add, and then we could pass the identifier classified add 2. Right? So if you want to create a new ad this way, or you can use the add method to add to use the add method to add classified add 2. How many times can you say the word add? But these are two different ways of adding items to a list after it's been created. So this is 3 ways of adding items to a list.
I have a question.
Yeah.
So where you typed use mattresses and number of words equals 0, could you have that equal to a text box so a user could input it just that way?
Yeah, so like let's just say this one, we'll say text category dot text, and number of words is int dot parse text number of words dot text. So this item in the list we'll get from the text box. And so you can see gibberish has 123 words and costed 1107.
Okay, cool.
Because category takes in a string, so the category property is a string, and so it accepts a string, so we can assign a string. This one we had to parse to an int because number of words accepts an int. Like here we go, these are all ints, so we just can't pass the text property directly, we got to go ahead and parse it. Some of our best work can be done remotely. I love it. Let's see which one I want to do next. Sales several channels, fields, read-only fields, 3 constructors. Okay, we'll do number 3 because it does more with constructors. And there's new concepts here. Again, different books, so different concepts that were covered in these different chapters, but I can cover the concepts because it's all part of C#. So let's do one more problem, and then we'll go into labs. So sales transaction. Okay, so you make a sale, so the objects are called sales transaction objects. So we'll make a class called sales transaction. You know, so we're capitalizing the S, capitalizing the T. Our classes are going to follow that Pascal casing. Displays their values and their sum. All right. The sales transaction class contains fields for a salesperson name, an amount, and a commission that's read-only field. We've done read-only properties, but we haven't done read-only fields. So we'll talk about read-only fields. So let's go ahead and start with the name and the amount. And how about that? Private double sales amount. Or I guess we can make it a decimal. And their sum. I'm not sure what they mean by and their sum, but I'll come back to that. The salesperson's name, the sale amount, and commission. And a read-only field that stores a commission rate. And commission. So commission is a field. So private decimal. So this would be like commission amount. So how much commission you made. And a read-only field that stores a commission rate. So commission amount is different than your commission rate. That's a dollar amount that you made in commission. Commission rate, private, read-only, decimal, commission rate. Now what read-only means, let's talk about a read-only field. So again, these are instance fields. And read-only instance field means you can only set the value in a constructor. And so if we kind of break this down just a little bit more, right now to set values we can use mutator methods, we can use set properties, or constructors. So these are our fields. There's 4 fields. And we've learned 3 different ways to set these values. mutator methods, which are like a method called set salesperson, set properties, which would be a property called salesperson name, and constructors. Constructors are methods that have the same name as the class. Read only says, hey, you can only set the value in the constructor. So it's kind of a restrictive way. What is unique about a constructor? What is unique about a constructor? Let's remember a constructor is a method that sets the values of the instance fields when the object is created. So objects have a life cycle, and constructors set the fields at the beginning of the object's life. So like as a human being, you're born and you're given a name immediately. Like you're constructed with a name, if you will. You cannot set the person's name when they're 5 years old, like later on in their life. You've got to construct the person with a name. Am I right about that? Like you pretty much legally have to give someone a name immediately? It's a silly question, but do you get the reference?
I have no idea.
Do you follow the reference, or have I lost you?
No, that makes sense.
All right. Anybody else? You guys following?
Can you say it one more time?
Yeah. So a constructor says, hey, you've got to set these values when the object is created. So if you use a constructor to set the fields, you're doing it when the thing is born, when the object is born. Okay, and I said, just like a human being, you've got to set the human being's name when they're born. You cannot set the name later on in the human being's life. You've got to set the name immediately when they're born. That's like to say that the human being was constructed with a name. It's just a life cycle. The human being is born with a name, and your objects are born with the data that they're constructed with. So a commission rate says, hey, you've got to set the value in the constructor. That's basically what that means. You cannot set the commission rate in a mutator or in a property. That's a no-no. Okay. Include 3 constructors for the class. 1 constructor sets the values for the name, amount, rate, and sets the value. And when the sales value is set, the constructor computes the commission and sets the value times the rate. Okay. So there's a lot there. So let's just focus on 1 constructor at a time. So a constructor is a method with the same name as the class. So this is what's called the default constructor. We're not going to code the default constructor though. This says this constructor has values for the name, amount, rate. So let's put that in. So string sales person name, decimal sale amount, comma, the name, amount, rate. So the commission rate, so is a decimal commission rate. And it says when you set the sale amount and the commission rate, it also calculates the commission amount. Right? So that kind of makes sense. So there's 4 fields, and we're setting all 4 of these in here. Again, when the object is constructed or born, when the object is born, we're going to set all of the fields. So we're not using property, we're not using object initializers. It's kind of the same idea. Instead of using an object initializer, we're using the constructor. So we set the underscore salesperson name equal to salesperson name, right? So this field, if I just click it, you can see it's highlighting. It's setting the instance field equal to the parameter. And this is, again, this is the pattern that you can memorize. You set the instance field sales amount equal to the sale amount parameter. underscore commission rate equals commission rate parameter. So we set these three instance fields equal to these three parameters. But if you have a sale amount and you have a commission rate, you can also calculate the fourth field, which is the commission amount. You would say the commission amount equals, and you could use either one. You could use the, at this point, you've got the data in two places. You could use the parameter or the field. I'll just use the field. The commission amount equals the sale amount. Whoop. Sales amount. So like $10 times the commission rate. So what is this constructor doing? Before we move on, let's ask some questions. Let's have a discussion around the code that's been written.
So when you want to make an instance field read only, you just hardcode read only.
Yeah. Yep. And realize what that does. That means you cannot have a property to set the commission rate. You cannot have a property or a mutator method. You could only set it in the constructor as we've done here. Notice commission rate was set inside of this constructor. It was not set anywhere else. Actually, let me try and demonstrate that. Let me see if I can get this to compile public decimal a read-only field cannot be assigned to except in a constructor. Right? You see that? That's a demonstration of why this is read-only, so you can't do this. You have to set commission rate in a constructor. You can't do it elsewhere. Let's just glance at the problem. It does say you have three constructors. It says the second constructor has this, the third constructor has that. It has an overloaded plus operator. Well, that's kind of way outside the scope of what we've learned, but that's cool. So let's just demonstrate this. Keep in mind, a constructor is a way to put data into our objects when the objects are born. But I don't have any ways of pulling data out yet. Like this problem is not necessarily complete in the way that it doesn't describe how to pull the data out. Keep in mind, we've got kind of three ways to pull data out, right? So to get values, we have accessor methods, we have get properties, or toString. It's all about the data. The data is the most important piece. It's all about the data. So we need to write a way to get the values, and because the most condensed way to do that is in a toString method, I'm just going to do a toString. So I'll do public override toString, and I'm going to return. By the way, we're going to learn what this base toString is, but for right now, let's just delete it. And what are we going to say? We'll say Billy. Billy's our salesperson. Sold an item for sales amount and has a commission rate for a total commission of commission amount. So this is the salesperson name. And you could just do it like this, underscore salesperson name. Or you could do this dot underscore So this is the commission sales amount. So Billy sold an item for 20 bucks and has a commission rate of this dot underscore commission rate. So Billy sold an item for 20 bucks and has a commission rate of 50% for a total commission of $10. So it would be this dot underscore commission amount. Colon C. Commission rate. I believe percentage. I believe this will be like 10%. Sale amount is also a currency. And salesperson name. Okay, so we're putting data in using the constructor. We're pulling data out using toString. Questions on toString? Stay awake, guys. Stay with me. Let's hear from somebody we haven't heard from. Sam, you with me? Sam P, Sam D, Oladeji, Jacob?
Yeah, I don't really got any questions or nothing.
All right. Good to hear you, Jacob.
Yes, sir.
Sam D, I saw you unmute yourself. Mic test 1 2. Sam P is typing. Push to talk. 1 second. Oladeji is rejoining. Vinny is typing. George, how you doing? Derek, how you doing? You guys out there? We're doing roll call here. This is... Hello, world.
Hello.
I could turn on my webcam. I'm just eating breakfast.
How's the peanut butter sandwich going?
I'm not having one this morning. Not yet, at
What?
least.
What? Derek is good. That's good, Derek. George just unmuted himself. I think everyone's just getting their push to talk and all that, those settings going.
I found it.
Hey, George, how you doing? I heard you.
Wait, was I talking earlier?
No, Sam, we didn't hear you at all.
Oh, okay. I said I had no questions at the moment. Sorry.
Is this review helpful?
Yes.
So far, yep.
Good.
Yeah, I would say so.
Good. We've created the class. We have not used the class yet. The class has 4 instance fields. It has 1 constructor to put data into the instance fields. It has 1 toString method to pull data out of the instance fields. This is a write operation. This is a read operation. This is our data. The data is the most important piece. Are you tired of me saying that yet? The data is the most important piece. That's why everything exists. A big button. And a label called result. Oh, teacher, you gotta name your button. You gotta name your buttons. Button do something. Delete the click off of the... You click the lightning bolt and you can delete the click event, right? I showed you that before, but now the click event is gone, so it doesn't have a bad name. Now button do something's a good name. So what's our code here? It's all a class called sales transaction. Sales transaction, sale 1, new sales transaction. Now we're no longer using the default constructor. Inside of this parentheses, this is our constructor call right here. This is calling a constructor. This is calling the default constructor, but we don't have a default constructor anymore. Notice as I type the parenthesis, it tells me the information that it's expecting. It's expecting a salesperson name that's a string, a sale amount that's a decimal, and a commission rate that's a decimal. So George is our salesperson, sold something for 20 bucks, and the commission rate of 50%. That's a decimal 50%. Label result.text. Because we've coded a toString, we'll just say sale 1. Implicit call to toString. Cannot implicitly convert sales transaction to string. You making a liar out of me. I did it. What? Hold on. You're making a liar out of me. Sale 1. I demonstrated that in the last lab, did I not? Something's different. That's okay. I'm not going to battle it. Don't battle it. Let's see what my build errors are. Semicolon expected. In my toString. Oh, I bet you if
That's probably why. Yeah.
Yeah, if toString doesn't compile. No. Okay, let's build it again. Don't battle it. Put data in, pull data out. Don't battle it. Conform. George sold an item for 20 bucks, has a commission rate of 50%, has a total commission of $10. I mean, that's the bulk of this problem, is just doing it this way. To finish the problem, though, it does say 3 constructors, right? AKA overloaded constructors. It says the second constructor accepts the name and the amount, but sets the commission rate to 0. Well, so here's the deal. I guess some people don't earn commission. So we'll say public sales transaction accepts the string salesperson name and the decimal sale amount. And we'll set the salesperson name equal to the parameter. And we'll set the sale amount. You know, critiquing my own variable name, sales amount versus sale amount. Why is this one plural and this one singular? That's whatever. It says it sets the commission rate to 0. So if you use this constructor, it's the equivalent of you don't get commission. And anything times 0 is 0, right? So if the commission rate is 0, it's safe to assume the commission amount is also 0. Anything times 0 is 0. Right? So if you use this constructor, so how would you use that constructor? Sales transaction, sale 2 is a new sales transaction. Josh sold a $100 item, right? So now we can build a sales transaction, and if we again, it's still not liking my toString, so we'll code it. Let's put a line break in our toString. And let's do an append to the label so we're not overwriting the label. So Josh sold an item for $100, has a commission rate of 0% for a total commission of $0. So that is our second constructor. The third constructor accepts the name and sets all other fields to 0. So I guess this is just an employee that hasn't sold anything, I guess. So overloaded constructors here. Let's just do a public sales transaction string salesperson name. Salesperson name equals salesperson name. And we set the sales amount. Commission amount and commission rate. So this constructor sets everything else to 0. Using this constructor, we could just say this isn't even really a sale. We'll just call this employee. Yeah, whatever. We'll call it a sale. Sale 3 equals new sales transaction. Now check this out. You've now got overloaded constructors, and you could click through them to see which ones you want to use. Right? Remembering, you know, these are overloaded methods. All constructors are methods. And they're very much like our mutators. So I haven't made a sale. And label result.text plus equals sale 3 toString. Evan sold an item for $0, has a commission rate of 0, and total commission is 0. Last thing, something outside the scope of our book, but this is an overloaded plus operator that adds the sales values for 2 sales transactions objects. It's kind of interesting when you say, okay, we're creating our own things now, our own classes. So whatever thing we want to create, we can create a thing. And so what does it mean? You get to, when you're creating your own things, what does it mean to add those things together? And so you can actually take an operator like the plus sign and give it a purpose to say, okay, if we have these 2 things and we want to add them together, what exactly does that do? And so, give me a millisecond here. This is not. So this is kind of a funky syntax here. So what is this? This is a method that we're going to mark this method as static, and you're going to see what that means here in a minute. This method returns the sales transaction object, and and it inputs 2 sales transaction objects. So the idea is that we add 2 sales transaction objects together and we output the result of that. And my syntax: return new sales transaction. Let me read the problem. It tells us what to add together. This is try and get through this quickly. That adds the sales values for them together. So we're going to create 2 sales transaction objects, and this one will add this 2 sales values. The sales values are the sale amount, right? So we're going to add the sale amount together. And so the constructor that we can use, we could either use this one or use this one. I'm going to use this one because it's shorter. So like, let's just say Billy has 2 sales, and that we were going to add them together for the 3rd sale. So new sales transaction, S1 dot, we got, it's always going to be Billy. We're going to hard code Billy as the name, comma, and then the sale amount would be S1. I don't have a, see, this is the problem. I haven't flushed out this class to be able to do this yet. What I mean by flush out the class is I'm going to make some accessors to access the name and the amount. Because right now I only have a 2 string to get some data out. So let's go ahead and make a public string salesperson name, a get block to return salesperson name, public decimal sale amount, get block to return. Okay. This is where we're actually adding the sales amount together. So we're returning a new sales transaction object that takes in the salesperson name and then the amounts added together and returns that. So this is I don't know. This is okay. This is something that's out there where you say, okay, I've got these new objects. What does it mean when we add the objects together? Let me show you what that looks like. So here, Josh has a sales transaction of 100. Let's do sale 3 is also Josh. Has a sales transaction of 200. Sale 4 is sale 2 plus sale 3. So now this has meaning. This plus operator has been overloaded to now understand what this means. What this means is that sale 4 is going to be a new sales transaction object that holds the first name, which in this case both the names are Josh and Josh. So sale 2's name, which is Josh, so that's the salesperson, and then the amounts added together, S1 dot amount, S2 dot amount added together, which in this case would be 100 and 200 added together. So sale 3 sale amount, or I'm sorry, sale 4 sale amount would be $300. So if I output sale 4, let me just output sale 4. Josh was $300. has no commission, commission rate. Problem solved. Okay, that was not the most important piece, but it is something that's out there. So now you've seen what it means to overload an operator. In this case, the operator is the plus. So what does it mean? You get to define. What does it mean when you add objects together? I could say salesperson name 1 and a space and S2 dot. You could add the names together and add the amounts together. You get to define this. You get to define what does it mean to add objects together. Because by the default, there is no way to add objects together. It doesn't, like, you comment this out. Like, this is not possible. You can't add objects together because it doesn't know what it is.
So what if you wanted to just like do like 2 plus 2 later? Would it not do anything?
Good question. So like, hey, so when we talk about overloading methods, right? Just because we use one method doesn't mean we still can't use the other method. So when we add, you think about the plus operator. The plus operator can be used to add numbers, or it can be used to add strings. So like there's two ways that the add is already used, right? We're already using it. It's already an overloaded operator. You could use it in multiple ways. You see what I'm saying, Ryan?
Yeah.
So now we're just overloading another way that we could use the add operator. Now we could add numbers, we could add strings, or now we can add sales transactions. So that's what it means to be overloaded. It doesn't mean the other functionality goes away, but you can do more things with it. Good question.
Is the operator showing yellow to tell you that it's been overloaded?
I didn't even notice that. I guess it is yellow.
Yeah, I couldn't tell if it was a different shade or not.
Yeah, it kind of does. No, my question is, was that like, was that the case before? In other words, if I say int n equals 1 plus 2, yeah, there you go. It's black in this case. So that yellow, yeah, that must be an identifier to say, hey, this is I guess overloaded. I mean, that's what it is.
Yeah, because I thought for a split second when you did comment it out that it did turn back to black, but I wasn't 100%.
Yeah. Yep. Good observation. All right, guys, I'm going to stop the recording. Well, before I do that, any other questions? Covered a lot, I've reviewed a lot, hit some new concepts. For the recording, no more questions. Let's stop it.